Good afternoon, everyone. Can you hear me? Can you hear me? Okay, thank you for your response. In the previous class, we were discussing about equation of lines in vector form and Cartesian form, and also we had learned how to find the angle between two lines in a space, and also the condition for two lines to be perpendicular and two lines to be parallel. So let us do some problems related to that. Two lines to be perpendicular when A1 A2 plus B1 B2 plus C1 C2 equal to 0, where A1 B1 C1 are the direction ratios of the first line and A2 B2 C2 are the direction ratios of the second line. Similarly, if we are given the direction cosines, then we can write it as L1 L2 plus M1 M2 plus N1 N2 equal to 0. This also is the condition for two lines to be perpendicular. Similarly, two lines to be parallel when A1 by A2 is equal to B1 by B2, which is equal to C1 by C2. That is, the direction ratios are proportional to each other. Okay, we can apply this property to solve some problems here. Show that the three lines with direction cosines 12 by 13 minus 3 by 13 4 by 13 minus 4 by 13. Then the second one 4 by 13, 12 by 13 and 3 by 13. Now the third one 3 by 13 minus 4 by 13 and 12 by 13 are mutually perpendicular. We show that the three lines with direction cosines 12 by 13 minus 3 by 13 minus 4 by 13. This 4 by 13, 12 by 13 and 3 by 13. Then third set is 3 by 13 minus 4 by 13 and 12 by 13 are mutually perpendicular. So how can we prove this? A1 A2 plus B1 B2 plus C1 C2 is equal to 0. That is when the direction ratios are given to us. Here what are given? Here the direction cosines are given, that is L1 L2 plus M1 M2 plus N1 N2 equal to 0. This is what we have to prove. Consider the first set as L1. Take this as L1 M1 N1. This as L2 M2 N2. This as L3 M3 N3. So first you can find L1 L2 plus M1 M2 plus N1 N2. Find out the value of this. We have to prove that these lines are mutually perpendicular, that is perpendicular to each other. This is the first line, this is the second line, and this forms the third line. So here you have to prove that first and second line are perpendicular to each other, second and third are perpendicular to each other, and these two are perpendicular to each other. All these three cases you have to prove. So first you find out the value of this and give your answer. L2 L3 plus find out the value of all this. What's the value of the first one? It is 0, okay. This is equal to 0. Find out the second one. Okay, that also equal to 0. What about the third one? Okay, that also equal to 0. That is L1 L2 plus M1 M2 plus N1 N2 equal to 0 gives the first two lines are perpendicular. Then L2 L3 plus M2 N3 plus N2 N3 equal to 0 gives the second and third line are perpendicular to each other. Now third one, that is L1 L3 plus M1 M3 plus N1 N3 equal to 0 gives the first and third line are perpendicular to each other, which implies these three results implies the three lines are mutually perpendicular. Okay, let us move to the next question. Show that the line through the points show that the line through the points 1 minus 1 2 3 4 minus 2 is perpendicular to the line through the points 0, 3, 2 and 3, 5, 6. 0, 3, 2 and 3, 5, 6. Let us name the points here. Let the first set of points be A and B. So the points A, B1 minus 1, 2 and B 3, 4 minus 2. So 2 points A and B, the line through the points A and B. So if 2 points are given to you, you can find the direction ratios of this AB. Direction ratios of AB. How can you find the direction ratios here? Or what are the direction ratios of this line AB? Whenever 2 points are given to you, this x1, y1 is z1, x2, y2 is z2, then to write the direction ratios of this AB, x2 minus x1, y2 minus y1, z2 minus z1. So you have to find out the direction ratios. Find the value of x2 minus x1, y2 minus y1, z2 minus z1. That gives the direction ratios. It is 2, 5 and minus 4. Okay. 2, 5 and minus 4. And now let us write the next set of points as C and D. Now the direction ratios of CD. Find the direction ratios of CD. Okay, the direction ratios of CD are 3, 2 and 4. Now you got the direction ratios of AB and CD, that is A1, B1, C1. Here A2, B2, C2. How can you prove that these two lines are perpendicular? Here you are getting these values as A1, B1, C1, then A2, B2 and C2. How can you prove that these two lines are perpendicular? You have to find A1, A2 plus, find out A1, A2 plus B1, B2 plus C1, C2. So it is 2 into 3 plus B1, B2, 5 into 2, then plus minus 4 into 4. It is equal to 6 plus 10 minus 16, which is equal to 0. That is A1, A2 plus B1, B2 plus C1, C2 is equal to 0. So the line AB is perpendicular to CD. Is it clear? Okay, so Always remember this one. When 2 points are given to you, you can find the direction ratios of the line passing through the 2 points by finding x2 minus x1, y2 minus y1, z2 minus z1. You are getting the direction ratios. Similarly, you can find the direction ratios of the line CD. Then if a1, a2 plus b1, b2 plus c1, c2 is equal to 0, you can say that the two lines are perpendicular. If a1 by a2 is equal to b1 by b2 is equal to c1 by c2, you can say that the two lines are parallel. Okay, let us move to another question. Show that the line through the points show that the line through the points 4, 7, 8, 2, 3, 4 is parallel to the line through the points -1, -2, 1 and 1, 2, 5. -1, -2, 1 and 1, 2, 5. So as in the previous case, we can take the first set of points as A and B, 4, 7, 8. Then B is 2, 3, 4. Take C as -1, -2, 1. D as 1, 2, 5. Find the direction ratios of AB and the direction ratios of CD. Okay, the direction ratios of A, B are -2, then 3 minus 7, it is -4, then 4 minus 8, it is -4. Okay, -2, 4, -2, -4, -4, right? -2, here it is -4, this also equal to -4. Okay. Now what about the direction ratios of CD? That is 1 minus -1, it is 2. 2 minus -2, it is 4. 5 minus 1, it is 4. Okay. So we can consider this as A1, B1 and C1. This as A2, B2 and C2. Find out A1 by A2, B1 by B2 and C1 by C2. Find out A1 by A2, B1 by B2 and C1 by C2. This is equal to -1. B1 by B2 -2 by 2, which is equal to -1. Again -4 by 4, which is equal to -1. Last C1 by C2 is -4 by 4, which is also equal to -1. So we can write A1 by A2 is equal to B1 by B2 is equal to C1 by C2. Therefore, AB is parallel to CD. Okay, now let us move to the next one. Find the angle between the following pairs of lines. Find the angle between the following pairs of lines. The first one is r is equal to 2i minus 5j plus k plus lambda into 3i plus 2j plus 6k, and the second line is given as vector r is equal to 7i minus 6k plus mu into I plus 2j plus 2k. I plus 2j plus 2k. See here, the first question is given as find the angle between these two lines. So in which form it is given? Vector form or Cartesian form? It is in vector form. So you have to consider the standard equation of a line, that is vector r is equal to a1 plus lambda b1. Okay, and here vector r is equal to a2 plus mu b2. Compare with this standard form, and you know that this is the equation of a line which passes through the point 2, minus 5, 1 and is parallel to the vector 3i plus 2j plus 6k. Okay, and similarly this is the equation of a line which passes through the point 7, 0, minus 6 and parallel to the vector I plus 2j plus 2k. So here the parallel vectors are b1 and b2. So you have to write down this b1, vector b1 and vector b2. This is equal to 3i plus 2j plus 6k. This is 3i plus 2j plus 6k, and here the parallel vector is I plus 2j plus 2k. In order to find the angle between these two lines, it is enough to find the angle between these two vectors. And you know that cos theta is equal to b1 dot b2 divided by modulus of b1 into modulus of b2. This is the formula for finding angle theta, and this equals modulus here, modulus of this. To find the angle between two vectors b1 and b2, cos theta is equal to b1 dot b2 by modulus of b1 b2, the basic definition of dot product. So let us find b1 dot b2 here. When the vectors are given in component form, how can you find the dot product? It is multiplying the scalar components, corresponding scalar components. So it is 3 into 1 plus 2 into 2 plus 6 into 2. So this equals 3 plus 4 plus 12, which is 19. Also you have to find modulus of b1 and modulus of b2. Find out this. To find modulus of B1, root of 3 square plus 2 square plus 6 square. And here to find modulus of B2, 1 square plus 2 square plus 2 square. It is 7 and 3. 7 and here it is equal to 3. So we can apply these values here. This is equal to modulus of B1 dot B2 is 19 divided by 7 into 3. So which is equal to 19 by 21, or theta is equal to cos inverse 19 by 21. This is the angle between the two lines. Okay, now another question. Vector R equals 3i plus j minus 2k plus lambda into I minus j minus 2k, and vector R equals 2i minus j minus 56k. 2i minus j minus 56k plus mu into 3i minus 5j minus 4k. 2i minus j minus 56k plus mu into 3i minus 5j minus 4k. Compare this with the standard form. Vector R is equal to a plus lambda vector b. And find out the two vectors. Vector which is parallel to this line and the vector which is parallel to this line. That is vector b1 and b2. Which is vector b1 parallel to the first line? Which is the vector b1 here? I minus j minus 2k, that is the first one. Okay, I minus j minus 2k. And which is vector b2? b2 is 3i minus 5j minus 4k. So you got b1 and b2. Now as in the above case, you have to find b1 dot b2, then modulus of b1 and modulus of b2. Find out the value of b1 dot b2. Okay, it is 16. Now find out modulus of B1. Modulus of B1 is root of 1 square plus 1 square plus 2 square, which is equal to root 6, and modulus of B2. Okay, it is root of 50, that is 3 square 9 plus 25 plus 16, which is equal to root of 50. Now let us find the angle between them. Cos theta is equal to modulus of B1 dot B2 divided by modulus of B1 into modulus of B2. So this is equal to 16 divided by root 6 into root 50. You can write this as 5 root 2. We can simplify this one as 16 divided by 5 into 2, 10 root 3. Isn't it? You can write root 50 as 25 into 2, which is 5 root 2. Then this is root 2 into root 3. So it is root 2 into root 3. 5 into 2, it becomes 10, 10 root 3. Or you can simplify this as 8 by 5 root 3. And theta equals cos inverse 8 by 5 root 3. Okay, one more question. Find the angle between x minus 2 by 2 equals y minus 1 by 5 equals z plus 3 by minus 3. Z plus 3 by minus 3 and x plus 2 by minus 1 equals y minus 4 by 8 equals z minus 5 by 4. Find the angle between x minus 2 by 2 equals y minus 1 by 5 equals z plus 3 by minus 3 and x plus 2 by minus 1 equals y minus 4 by 8 equals z minus 5 by 4. So this in this question the equation of lines are given in Cartesian form, that is x minus x1 by a equals y minus y1 by, or you can write this as a1 by b1 equals z minus z1 by c1 and x minus x2 by a2 equals y minus y2 by b2 equals z minus z2 by c2. So which are the parallel vectors now? Which are the parallel vectors here? Okay, it is 2i plus 5j minus 3k is the first one. 2i plus 5j minus 3k. And the second one, second parallel vector is minus I plus 8j plus 4k. So once you identify these parallel vectors, the same procedure we have to do. Find b1 dot b2, then modulus of b1 and modulus of b2, then find the angle. Always this x1, y1, z1, x2, y2, z2 are the points through which the lines are passing, and the denominator tells us the direction ratios of the vector parallel to the given line. So if you form the vector here, that is the parallel vector. 2i plus 5j minus 3k. Here it is minus I plus 8j plus 4k. Find out the value of b1 dot b2. b1 dot b2. It is 2 into minus 1 plus 5 into 8 plus minus 3 into 4. This is equal to minus 2 minus 12 minus 14, 26. Okay. Okay, it is 26. Now modulus of b1 is equal to that gives root of 2 square, it is 4 plus 25 plus 9. Okay, it is root of 38, and b2 is b2, it is 1 plus 64 plus 16, that is equal to 9. Okay, now cos theta is equal to modulus of b1 dot b2 by modulus of b1 into modulus of b2. So this is equal to b1 dot b2 is 26 by 9 root 38, or theta equals cos inverse 26 by 9 root 38. I hope this is clear to you. So question number 11, the second part you do as homework. Okay, exercise 11.2. Exercise 11.2. Question number 11, part 2. Now another question. Find the values of P find the values of P so that the lines 1 minus x by 3 equals 7y minus 14 divided by 2p. This is equal to z minus 3 by 2. So 1 minus x by 3 equals 7y minus 14 by 2p equals z minus 3 by 2 and 7 minus 7x by 3p equals y minus 5 by 1, which is equal to 6 minus z by 5 are at right angles. Find the values of P so that the lines 1 minus x by 3 equals 7y minus 14 by 2p. This is equal to z minus 3 by 2 and 7 minus 7x by 3p equals y minus 5 by 1 equals 6 minus z by 5 are at right angles. That means these two lines are perpendicular. If these two lines are perpendicular, find the value of P. So always remember the standard form is x minus x1. So you have to write it in that form itself. X minus x1 equals y by a equals y minus y1 by b equals z minus z1 by c. See, the coefficients of x, y and z are equal to 1. So in that way you have to arrange these terms. Here it is 1 minus x, which we can write as x minus 1 by minus 3. So multiplying with a negative sign in both numerator and denominator, it becomes minus 1 plus x, that is x minus 1 by 3 equals. Here we have to make this coefficient 1. So first you have to take 7 as a common factor, which moved to the denominator, it becomes y minus 2 divided by 2 by 7p. 7 is a common factor in the numerator. When it moved to the denominator, it becomes 2 by 7 here. 2 by 7p. This is equal to z minus 3 by 2 is perpendicular to. Here also you have to change this. 7 is a common factor and this is negative. So you have to take minus 7. Then it becomes x minus 1 divided by minus 3 by 7p. 7 is a common factor and minus 7 is as a common factor. So this becomes plus x. This becomes minus 1. And here the common factor from the numerator becomes minus 3 by 7p. This is equal to y minus 5 by 1. This can be written as z minus 6 by minus 5. Okay, these two are perpendicular. Now this is in standard form. X minus x1 by a1 equals y minus y1 by b1 equals z minus z1 by c1, perpendicular to x minus x2 by a2 equals y minus y2 by b2, which is equal to z minus z2 by c2. So to apply the condition for perpendicular lines, this is a1, a2, minus 3 into minus 3 by 7p plus 2 by 7p into 1 plus 2 into minus 5. 2 into minus 5 equal to 0. Since these two lines are perpendicular, a1 a2 plus b1 b2 plus c1 c2 is equal to 0. From this you can find the value of p. Simplify it and get the value of p. This becomes 9 by 7p plus 2 by 7p plus minus 10 is equal to 0, or you can write this as 11 by 7 p equals 10, which implies p is equal to cross multiplying, you will get this as 70 by 11. So the value of p is 70 by 11. Okay. So always remember to write this in standard form. Whenever the equation of two lines are given in Cartesian form, check whether they are given in standard form, that is x minus x1 by a equals y minus y1 by b equals z minus z1 by c. Is it clear? Okay, so let us move to the next one. Show that the lines x minus 5 by 7 equals y plus 2 by minus 5, which is equal to z by 1 and x by 1 equals y by 2 equals z by 3 are perpendicular to each other. Are perpendicular to each other. How can you prove this? Find out a1 a2 plus b1 b2 plus c1 c2, a1 b1 c1 a2 b2 c2. Since these are given in standard form, x minus x1 by a1 equals y minus y1 by b1 equals z minus z1 by c1, and here also standard form. So find out a1 a2 plus b1 b2 plus c1 c2. Value is equal to 0. Okay, 7 into 1 plus minus 5 into 2 plus 1 into 3, which gives 0. Therefore, the two lines are perpendicular. Okay, now the next topic is distance, shortest distance between two lines. Next heading, shortest distance between two lines. See, there are three different cases. The first one is if two lines in space intersect at a point, then the shortest distance between them is see, two lines are intersecting lines, intersecting here. So the shortest distance here, this, if you draw a line like this is the distance between these two lines. You can draw a line here that gives the distance between the two lines. Then the shortest distance is here and it is equal to 0. If two lines in a space intersect at a point, then the shortest distance between them is 0. Okay, this is the first case. Now the second one is if two lines in space are parallel, then the shortest distance between them is the perpendicular distance between them. Perpendicular distance between them. And see, if two lines in a space are parallel, see the two lines are parallel, then the perpendicular distance between this is the shortest distance. And we can find it. See, two lines are given, A plus lambda B. This is one line. Another line which is equal to, let us write this as A1, A2 plus mu vector B. So this is how you can identify parallel lines. See, the point or the position vector of a point through which the line passes, that will be different here, a1 and a2, but here the parallel vectors are same. To identify parallel lines in a space, you can use this r equals a1 plus lambda vector b, r equals a2 plus mu vector b. These two vectors are same. So to find the shortest distance between them, the distance is denoted by d, and this is equal to modulus of b cross vector b cross a2 minus a1, a2 minus a1, vector b cross a2 minus a1 divided by modulus of vector b. This is the formula we have to use here. The shortest distance is denoted by d, and this is equal to, common vector here is vector b, b cross a2 minus a1 divided by vector b. We are considering the cross product here, then divided by its modulus of this common vector b. Okay, now let us consider an example for this. Write as a question, find the shortest distance between the lines L1 and L2 given by vector r equals I plus 2j minus 4k plus lambda into 2i plus 3j plus 6k and vector r equals 3i plus 3j minus 5k plus mu into 2i plus 3j plus 6k. This is how you have to identify parallel lines. See, lambda into vector b, mu into vector b, these two vectors are same here. So the two lines L1 and L2 are parallel. So the shortest distance can be found by modulus of b cross a2 minus a1 divided by modulus of vector b First let us find this b cross a2 minus a1. To find the cross product, b cross a2 minus a1, to find the cross product we have to consider the determinant. The first row is I, j, k. Then since it is b cross a2 minus a1, the first we have to write the scalar components of vector b. Vector b is 2, 3, 6. Then b cross a2 minus a1 we have to find. This is a1 and a2. You have to write a2 minus the scalar components of a2 minus a1. So it is 3 minus 1, which is 2, 3 minus 2, which is 1, minus 5 minus 4, which is equal to minus 1. So find out the value of this determinant. This is minus 3 minus 6, which is minus 9i into, then minus j into minus 2 minus 12, which is minus 14. So it becomes plus 14j, then k into 2 minus 6. So it is minus 4k. So you got B cross A2 minus A1. Now this modulus is applicable only to this numerator, as this is the vector here. Since this is a real number, this modulus can be applied here. So that equals modulus of minus 9i plus 14j minus 4k divided by, what is modulus of b? What is modulus of b? Modulus of vector b equals root of 2 square plus b is 2i plus 3j plus 6k. So its modulus is 2 square plus 3 square plus 6 square. It is equal to 7. Okay, this is equal to 7. What about this modulus? What about modulus of this vector? You can find it root of 9 square plus 14 square plus 4 square. What's the modulus of this? 9 square it is 81, 14 square is 196 plus 16. It is root of 293. Okay, right. Root of 293 divided by 7. This is the shortest distance between these two parallel lines. Okay, is it clear? So remember this one. First we have to find B cross A2 minus A1. Find out a vector and find its modulus. Then that divided by modulus of vector B gives the shortest distance between the two parallel lines. Okay. Now the next one is, one more case is there. The third case. In space, there are lines which are neither intersecting nor parallel. Such pair of lines are called are non-coplanar and are called skew lines. This is the third case. If the lines are not intersecting and not parallel. This pair of lines are non-coplanar, that means they are not lying on the same plane and are called skew lines. These are called skew lines. Now to find the shortest distance between skew lines, we can use this. D equals modulus of B1 cross B2 dot A2 minus A1 divided by modulus of B1 cross B2. Modulus of B1 cross B2. So here B1 cross B2 dot A2 minus A1 divided by B1 cross B modulus of B1 cross B2. Derivation is not required here. See, in the previous case that the lines are parallel, then B is same in both the equations. So we are writing B cross A2 minus A1 divided by modulus of B. Here we are using B1 cross B2, that is vector R is equal to A1 plus lambda B1, and another line vector R is equal to A2 plus lambda B2. In this case, the shortest distance between the two lines is B1 cross B2 dot A2 minus A1 divided by modulus of B1 cross B2. So let us consider an example. Find the shortest distance between R equals I plus 2j plus k plus lambda into I minus j plus k and vector R is equal to 2i minus j minus k plus mu into 2i plus j plus 2k. 2i plus j plus 2k. So here this is of the form a plus lambda b a1 plus lambda b1. This is a2 plus mu b2. So we can write this as mu b2. So in this case, to find the shortest distance between this, we need b1 cross b2 dot a2 minus a1. See, to find out this cross product and this dot together, we can write this as D is equal to, numerator can be written as x2 minus x1, y2 minus y1, z2 minus z1. First row of the determinant is taken as a2 minus a1 here. All the three scalar components, x2 minus x1, y2 minus y1, z2 minus z1, instead of taking I, j and k. Then B1 cross B2, this is B1 and this is B2. So to find the cross product, we are writing I, j and k. Instead of that, we wrote a2 minus a1 here. Then a1, b1, c1, direction ratios of the first vector b1, then a2, b2, c2, this divided by, this is determinant, divided by modulus of b1 cross b2. So let us apply the values here. Determinant x2 minus x1, y2 minus y1, z2 minus z1 in this case. 2 minus 1, it is 1. Then minus 1 minus 2, it is minus 3. Then minus 1 minus 1, it gives minus 2. x2 minus x1, y2 minus y1, z2 minus z1. 2 minus 1, minus 1 minus 2, then minus 1 minus 1. Okay, now a1, b1, c1 is, what are the values of a1, b1 and c1? That is, here you have to write the scalar components of this vector. a1, b1, c1. It is 1 minus 1, 1. 1 minus 1, 1. Now a2, b2, c2 is the scalar components of the second vector here. 2, 1, 2. It is 2, 1, 2. Then divided by, to find this b1 cross b2, modulus of b1 cross b2. We can use this determinant itself. See, minus 2 minus 1 the whole square, minus 2 minus 1 the whole square, plus 2 minus 2 the whole square, plus 1 plus 2 the whole square. This gives square root of, this gives the modulus of b1 cross b2. So if you write this determinant from this itself, you can write the value of modulus of b1 cross b2. Is this step clear to you? See, remember, in the determinant, in the numerator, you have to write the first row as x2 minus x1, y2 minus y1, z2 minus z1. The second row is the direction ratios of the first vector b1. Third row of this determinant is the direction ratios or the scalar components of the second vector b2. Then using these two rows, we can write the modulus of b1 cross b2, that is minus 1 minus 2 sorry, minus 2 minus 1 the whole square plus 2 minus 2 the whole square plus 1 plus 2 the whole square. Is this clear? Okay, now find the value of this determinant. One into minus 2 minus 1 the minus 2 minus 1 minus 3, that is plus 3 into 2 minus 2, then minus 2 into 1 plus 2 divided by, this gives minus 3 square, that is 9 plus 9, 18, root of 18. This is equal to minus 3 minus 6, which is minus 9 by root 18. This can be written as minus 9 divided by, so here you have to consider a modulus of this. Since it is the distance, we cannot take negative sign here. So modulus of this gives plus sign. 9 divided by root 18 can be written as 3 root 2, or this becomes 3 by root 2, or rationalizing the denominator you will get this as 3 root 2 by 2. See, only you have to remember this part of the result, that is the first, this is a determinant, and the first row is x2 minus x1, y2 minus y1, z2 minus z1. Then second row, the scalar components of the first vector b1. Second row, third row is the scalar components of the second vector. Then using these two rows you can find modulus of b1 cross b2. Then take its modulus. It gives the shortest distance between two lines. Try these questions also yourself. 15, 16 and 17 of exercise 11.2. Okay, exercise 11.2, question number 15, 16 and 17. And we will move to the next topic in the next class. Thank you.